Okay, now we have the cosine rule. This is also one that is in your formula booklet. This one's a little bit harder to use just because there's more involved. You can see the formula here. Essentially, I always try to do law of sine. I think it's easier to use, it's easier to set up, but if you don't have a complete pair, you can't do the law of sine. So a question is not going to say use law of sine now, use law of cosine now. Personally, I try to use law of sine, and if I can't, I try to use law of cosine. So essentially for the law of cosine, you're going to have one of two scenarios. You're either going to have side angle side, or you're going to have all three sides. So this first equation right here, this is going to be the one that you would use if you know side angle side. And that's going to be something like this, ABC. So let's say that I know angle A, then I would need to know B, and I would need to know C, and see that side angle side right there. And then I would be finding A. So I know C, I know B, and I'd be finding A. The other scenario is, what if you know all three sides? So if I know side, 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 so in this case, if I knew all of the sides, let's say, then I can find the angle here for A. And I could really find any of them. It's just a matter of how it gets set up. Now, in pre-cal or in Algebra 2, you may not have used this formula right here. Honestly, I don't normally use this formula. I use the first formula here for everything, and if I need to know A, then I solve for A. But you have both of these, so I'm going to show you how to use this formula because you may end up liking that one better. Again, these are both given to you in your formula booklet, but you may not be doing A, you might be doing B, you might be doing C, you might be doing D, E, F. They might not have given you letters at all. So you have to be able to manipulate these formulas to make them what you need to be. Just like with the other questions here, make sure that you are doing as much as you can in your calculator to get an accurate answer. Use that answer key. Don't do baby steps in some situations. And again, make sure that you are in degree mode. So, first one here, I know angle B. I have little letter A and little letter C. So, ABC, 40, 12, and 20. And in this case, see my side angle side. So, what's going to be the easiest for me to find here first is going to be B. So, I'm going to take that formula up here, and I'm going to switch it around to be B, because I know angle B. Now notice this angle here is always the same as this. And notice that this angle here is always the same as this segment here that is subtracted. Okay, that's how you're going to be able to rewrite these things. So in this one, since I know angle B, I'm going to be using this formula. B squared is equal to A squared plus C squared minus 2AC cosine of B. So notice B and B, that's the angle that I have, that's the side that I'm going to find, and then the other two sides right here. It doesn't really matter the order of the two sides, it's just a matter of your angle here has to correspond with this letter over here. Okay. So I set that up now. B squared is equal to 12 squared plus 20 squared minus 2 times 12 times 20 cosine of 40. Now, I do not expect to see any work on any of this right here. Type this in your calculator all in one step. When students don't, a lot of times they get themselves into trouble. For example, right here, this is attached to the cosine of 40. So you cannot do 12 squared plus 20 squared minus this, get an answer, and then take that times the cosine of 40. It's wrong, okay? This is all one thing. So just type that in all in one step. Now what I would like you to do is to tell me what do you get as an answer. Just because that kind of shows us we're on the same path. Okay, that's not your answer. I don't want you to round it. I kind of want you to do the square root of your answer. So the square root of that is going to give me 13.3. Okay, so in the calculator, just in case you need to see that, that's going to look like, hold on here just a second. Okay, that's going to be 12 squared plus 20 squared minus 2 times 12 times 20. There really is no reason to have those in a parenthesis. I think I had parentheses written on your paper there a minute ago. That's okay. Cosine of 40. I hit enter. Okay, so that's the number that I wrote down, but said, hey, don't really round this. Okay, I'm going to do the square root of that answer. Okay, and again, I hit second and the negative key to get that, or you could have stored it. And I end up with 3 sig figs again, 13.3. Okay, so now I know the 13.3, so let me put that in here. And now, what do you know? I've got a complete pair. So oftentimes what you can do in this case is you can switch to law of sine. I actually am not going to do that though, because it looks like I wanted to show you how to use the other formula up there. So in this case now, let's find angle A. Okay. So with angle A here, I told you up here with this one, well, it's the same, this is the exact same setup, but the angle A here is going to correspond to that side here that's being subtracted. So that's going to look, well, let me just go ahead and write the formula down here. Cosine of A is B squared plus C squared minus A squared over 2BC. Now again, I'm really not sure why I'm doing law of cosine here, because honestly I would do law of sine, but we'll end up with the same answer. The cosine of A would be 13.3 squared plus 20 squared minus 12 squared. I'm going to divide that by 2 times 13.3 times 20. Now when you do this in the calculator, you're going to want a parenthesis around all of this and a parenthesis around all of that. Or you can baby step, do the top, hit enter, and then divide by the bottom, and then you'll have to do one set of parentheses. We end up with the cosine of A is approximately 0.8137, and then of course we would do our inverse of answer to get that A is approximately 35.5. And I'll show you that math in the calculator here in just a second. And then to find C, of course, we're just going to take 180 minus B minus A, and I get 104.5. Okay, so let me go back up here and show you how we got the 0.8137 and how we got the A here. So again, my top was going to be all in a parenthesis, so 13.3 squared plus 20 squared minus 12 squared, close the parenthesis, divided by 2 times 13.3 times 20. Okay, so that's the number again there that I said don't round it, but we're going to do the inverse of that. So inverse cosine of answer, 3 sig figs, again 35.5. Now, also be careful with the law of cosine. Sometimes students actually do the law of cosine, but they actually do sine instead of doing the cosine. The law of sine is a thing, but it's not written in a similar manner to the law of cosine. Definitely not. Okay, so another one here. This one I have all 3 sides. Now, it's really not going to make a difference too much with what we're going to do, but I don't think, at least, but just to be safe, whenever you know all 3 sides, start with the largest angle first, and the largest angle is always across from the largest side. So in this case, since 10 is my largest side, let's find angle C first. Plus, that'll give me a chance to switch that formula around to find different angles here. So I want to find angle C, 8, 10, 5. So if I'm looking for angle C, remember up here I said that whatever the angle is, it's going to correspond to that side that's being subtracted. So the other 2 sides, it doesn't matter which order you put those in, but I'm looking for angle C, so this is going to be A and B. So the cosine of C, that's the one I'm looking for, is equal to A squared plus B squared minus C squared. Again, this letter here should match the letter over here. over 2AB. Notice the bottom is not the same letter as what's over here. Okay, so that's my setup here. That's going to be the cosine of C is equal to 8 squared plus 5 squared minus 10 squared. Again, that should all be in a parenthesis. Divided by 2 times 8 times 5. So the cosine of C is approximately negative 0.1375. And actually, I think it's exactly, I don't think it is approximate, it's exactly negative 0.1375. I'm going to do the inverse. And actually, I'm going to do inverse answer, even though I think that is exact, because it's less buttons to push, because I can just hit second and the negative key to bring that up. And I end up with C is approximately 97.9. Now, I didn't do this in the last question, but again, I don't know why I didn't, because personally, I hate using this formula. So being that I'm going to have to find 2 more angles, and I don't have enough, obviously, to subtract from 180 yet, I'm going to use law of sine to find another angle. So I can find whichever one I want next. I'm going to find A. So here's my complete pair. I know that one of them's in the decimal, but that's not going to matter. No matter what I do to find something else, even if I use the other law of sine formula again, I'm going to be using a decimal. So there's my complete pair for law of sine. I said I was going to find A next just because. So 8, they're all used with my law of sine to find my A. Okay, so that's going to look like this. 8 over the sine of A is equal to 10 over the sine of 97.9. Now, it doesn't matter which order you write these fractions in. We cross multiply, and I end up with 10 sine of A is 8 sine of 97.9. So sine of A is 8 sine of 97.9 over 10. Okay, we put that in the calculator. Remember, make sure you close the parentheses on that. I get the sine of A is approximately 0.79. Again, don't round that though. The inverse sine of answer gives me that A is approximately 52.4. Okay. Of course, now that I know that second angle, I can just subtract from 180 to find the third. So 180 minus C minus A will give me B. B is approximately 29.7 degrees. So when you're doing these problems, and then this is going to be more like what it's going to be on the test, yet I'm not going to tell you use law of sine, use law of cosine, use right triangle trig, use Pythagorean theorem. You're going to have to think about the problem and then figure out, okay, how can I solve this? And in some cases, there might be more than one way. Here, I could have done this more than one way. Again, I could have used the same formula I used here. Over here, I used this crazy formula, but I could have used law of sine. But I cannot use Pythagorean theorem. We do not have right triangles. Okay, 2 more here. Okay, so we have a story problem. We're going to approximate the length of a lake. So a surveyor starts at one end of the lake, walks 245 meters, turns 110 degrees, and walks 270 to the other end of the lake. Approximately how long is the lake? And if the surveyor could walk on water at a rate of 0.5 meters per second, notice I warned you about this, that's something you might see, that s to the -1 means meters per second. Same thing as being 0.5 meters over seconds. How long would it take to the nearest second to walk across the lake? Okay, so first let's start with this x here. So when it says that we turn 110 degrees, that turn is actually occurring outside of the triangle that I'm drawing. I know that this is a straight line, so if this is 110, then that means that this has to be 70. Okay, so I have side angle side. Here's my side, here's the side, and I've got the angle in between there. So we're looking for x here. So x squared is going to be 270 squared plus 245 squared minus 2 times 270 times 245 cosine of 70 degrees. Now notice, I didn't say this is A, this is B, whatever. I just went ahead and plugged it into the formula. Let me actually, I really should have done this already, sorry. So this is what I was modeling it as. I said that x was really like the same thing as a. The main thing is that this side here matches this angle here, and then the other sides are just the other sides. Okay, so we type that in our calculator all in one step. I get that x squared is approximately 87,675.74. Again, don't round it. Take the square root of this exact number that's in your calculator, and I get 296.1. So 3 sig figs, 296 meters. Now, if you remember before, we talked about rate, that I have this formula. The formula is distance equals rate times time. So how long would it take to the nearest second to walk across this lake? So I have my distance. I know my rate. My rate is 0.5. I'm looking for my time. So I'm going to divide my meters by my 0.5 there. So my time is going to be 296 over 0.5. Now, because my rate was in meters per second, that means I'm going to be given an answer in seconds, which is what they asked for. And that's going to be 592 seconds. Now, if they ask for minutes, then convert that to minutes, divide by 60 to do that, and be, of course, a little bit less than 10 minutes there. Okay. All right, last one here, we have a quadrilateral. Of course, you can see in this quadrilateral, because the way they've drawn it here, that I do have two triangles. And the information that's here, sometimes all this information is already in the picture, sometimes it's not, so do make sure you read through it. AB is 56, so that's in my picture. AD is 122, that's in my picture. CD is 40, that's in my picture. BAD is 68, so that's this whole thing right here. And 80 is my ADC. Okay, so this one's a little hard to read here, but they told you that that's 68. I'm just going to kind of rewrite that out here just so we can see there. Okay, so first thing they want me to do is they want me to find the length of AC. So here is AC. I kind of put that in red a little bit here. So look what I've got here. This triangle here, I don't know enough. Like all I know is this 56, the 68. Don't assume that that's cut in half. I have no reason to believe that. That's not enough information just to find that side. So focus on this triangle here. I've got a side, an angle, and a side. So what do you know? This will allow me to find the side across from it, and that's the side that I want. So in this case, AC squared would be 122 squared plus 40 squared. Doesn't matter which order you do that in. Minus 2. Don't forget the 2. That's easy for even me to forget. 2 times 122 times 40. And look here, I'm doing it too. It's not sine, it's cosine. Cosine of 80. Okay, so type that in your calculator. I get that AC squared is equal to approximately, actually I didn't write that one down. So this time we're just going to say that AC is equal to 121.6. So 3 sig figs, that's going to be 122. Now, this type of question, there's too much to do here. They're not going to expect you to be carrying these values over. Now, one thing to keep in mind, though, okay, so that's 122 for that red line there. It's not really 122. So we talked a little bit about isosceles triangles already. This is not an isosceles triangle. So you can't assume that if this is 80 over here, because it's not really 122. It's really 121.6. Okay. Now, Part B says find the angle DAC in degrees to the nearest tenth. So DAC is the bottom part of this angle that I know that the entire thing is 68. So looking at that, okay, so I want to find this angle. I've got the side across from it. And here's an angle with the side across from it, so I can use law of sine. That's what I'm going to do. I could use law of cosine because I've got all three sides, but again, that formula is way more complicated. So let's use the sine rule. So let me draw this out here so you can see what we're dealing with without all the other stuff going on. So 80, 122, 122, 40, and then my angle. And actually, let's get rid of this because we don't need that number right there. Okay, so I've got 40 sine of, let's just call it x, okay? But that is going to be DAC, but that's a lot of letters to write, is equal to 122 over the sine of 80. Be really careful here. I almost wrote the sine of 122. Make sure that your angle goes with the sine and that your side goes on the top there. So we're going to cross multiply here. 122 sine of x is 40 sine of 80. Sine of x is 40 sine of 80 over 122. So we're going to come up with that decimal. That decimal tells me that sine of x is approximately 0.32. So we're going to do an inverse sine of answer. And of course, x is really DAC. So DAC is equal to approximately 18.8 degrees. Okay. All right. So next, we're going to find the shortest distance between point B and AC. So the shortest distance is going to be at a right angle. So to kind of mess this picture up even more, that would be the shortest distance right there. Okay. Now, hold on, I didn't mean to label that B. Let's label that D for distance. Okay, now the shortest distance, like I said, is at a right angle. I'm looking for that value right there. I've got a right triangle right here. See this triangle right here? I know this hypotenuse. If only I knew this angle, well, we know what? I do, because I know this much is 18.8. I can subtract to find that top part. So let me show you the triangle that we've got going on here. So just this left-hand side of this triangle, okay, here's D, here is 56, and again, this entire angle is 68, so if I subtract the 18.8 from it, that means the top of that angle is 49.2. Okay, so I can use just regular old sine here. Sine of 49.2 degrees is equal to D over 56. So 56 sine of 49.2 is equal to D. D is approximately 42.4. All right, last part. Find the length of the perimeter of triangle ABC. Okay, so to find the perimeter, I need all three sides. Right now, I currently only have two sides. I have the 122-ish, because we rounded that. I've got the 56. I need this side right here. So, okay, I always like to try to do law of sine if I can. In this triangle, though, right here, I know this angle here, not the 68, but the 49.2. But that's the only angle that I know. And in order to do law of sine, I need to know another angle. So this is going to have to be cosine. So to find BC then, let me draw this triangle. Actually, let me draw the triangle right here because I'm afraid I'm not going to have room. This is 56. This is 49.2. This is 122. And I'm looking for BC. Okay, so BC squared is equal to 56 squared plus 122 squared minus 2. Don't forget the 2. 56, 122. Cosine, not sine, 49.2. Type that in your calculator all in one step. Take the square root, and I end up with BC is approximately 93.7. So perimeter then is going to be 56 plus 122 plus 93.7, and that gives me 272 meters. Now that's rounded to 3 sig figs there. Okay. All right, again, let me know what you need help with. There's going to be a lot of, in this case, again, mixing. Law of sine, law of cosines, right triangle trig. Could be Pythagorean theorem, but make sure you've got a right triangle to deal with there.